How is STEM incorporated into physical therapy?
Hi, my name is Jessica Allen, and I am a professor in the Biomedical Engineering Department at West Virginia University. As part of my job, I have two major roles. One is to teach biomedical engineers about the principles of biomedical engineering. But the second role is as a scientist, where I study the field of biomechanics. And so first I'll introduce to you what I mean by the word biomechanics. It is one of those words that means what it says. If you think about it, it is the application of mechanics to biological systems. So I'll speak a little bit to mechanics in a minute, but what do I mean by biological systems? Well, of course, humans are biological systems, and that's primarily how I'll be answering the question today. But biological systems also include things like animals, even go smaller to things like bugs, whether those are flies or ants. You can also look inside an organism and study the biomechanics of bone. This might be important, for example, to understand how bone breaks happen and how you should heal them. You can even go further and study the biomechanics of cells, and you can even study the biomechanics of things like plants. Of course, when we talk about physical therapy, we probably are going to be talking about the biomechanics of humans. So the mechanics part is primarily driven by what are called Newton's 3 laws of motion. So you may or may not heard of these laws, but you may have heard of Sir Isaac Newton, who back in the 17th century, as the story goes, had an apple drop on his head, and he came up with these laws of motion. So there's 3 laws. The first law is that any object at rest is going to stay at rest until a force acts upon it. So for example, as I'm standing here, I am at rest. I will stay at rest unless someone pushes on me. Once someone pushes on me with a force, I might fall over. As part of this first law, you also have that an object at motion will stay in motion unless acted upon by an external force. So after I've been pushed, as I start falling, I'm going to continue to fall unless I apply forces. Those forces are going to come from my muscles. Why is this important for physical therapy? Well, if my muscles are weak, I might have a problem preventing a fall. And so if that's the case, I might be prescribed to do exercises to strengthen my muscles. Newton's second law is that the amount that I'm going to move is going to be related to how heavy I am, as well as the force that's applied to me. It also means that depending upon how fast I'm moving, I might have to apply larger forces from my muscles to prevent a fall. Newton's third law of motion is that every force is going to have an equal and opposite reaction. So for example, as I'm standing here, gravity is acting on me, which means that I'm applying a force to the ground. In order for me not to fall through the ground is applying a force back on me to prevent me from falling. You can also think of that as if I push against this wall here, I am applying a force, and the structure here is applying a force back on me such that it doesn't move. All right, now that I've introduced to you what Newton's 3 laws are, let's talk a little bit about how those might apply to human movement and influence physical therapy. So, as I mentioned, forces are what produced movement. As a human, our forces generally come from our muscles. So for example, if I were to try to hold this weight here in this position, remember gravity is acting down on it, and so that's what makes this weight heavy. And in order to prevent my arm from falling like this, I'm going to have to use the muscles in my arm to produce a specific force. Similarly, if I want to start using or doing a biceps curl, I'm going to have to coordinate all of these muscles to generate specific forces. I can also move this dumbbell by doing biceps curl by coordinating the forces in all of the muscles surrounding my elbow joint. So how does that apply to physical therapy? Well, you need to know the biology, the physiology, as well as the neuroscience behind how the brain coordinates the muscles. But you also need to know how those muscles are going to generate forces and act on the skeleton, and that is the mechanics part. If I have trouble doing this biceps curl, again, maybe I will be prescribed interventions to strengthen my muscles. So as a biomedical engineer that studied biomechanics, I work a lot with physical therapists. Physical therapists also need to understand biomechanics, and they are taught that a lot during their training. This is often referred to as a field of kinesiology, but kinesiology and biomechanics are similar. Essentially, as a physical therapist, in order to be able to understand and prescribe rehabilitation, you need to understand the underlying interactions between muscles and the skeleton. And that's exactly what we talked about when I introduced biomechanics. So my one piece of advice, or rather two pieces of advice for you, is when you're young, if you find something interesting, don't let other people tell you that you can't do it, because you can. The second thing is it's okay to change your mind on the things that you find interesting and to continue along your path and just continue learning new things. And you'll be surprised that a lot of the things you learn actually help you be better at whatever it is that you end up doing.